Hello everyone. Today we are going to discuss the problem common in three sorted arrays. So it is a difficulty easy question. So given three sorted arrays in non-decreasing order. So we need to print all common elements in the non-decreasing order only. In this across three arrays. So if you see, if there are no such elements, then return an empty array. In this case, the output will be -1. So the note is, can you handle the duplicates without using any additional data structure? So we will handle only using our code efficiency. So if you see the first example, the input is ARR 1 is equals to 1, 5, 10, 20, 40, 80. Array 2 is 6, 7, 20, 80, 100. Array 3 is 3, 4, 15, 20, 30, 70, 80, 120. So the output is, you can see from the three arrays, the sorted arrays, the common elements are 20 and 80. So the output is 20 and 80 in the non-decreasing order only. So explanation is also same. So same with the other ones. So if you see the expected time and space complexities, the time is big of n and space is big of n. So simple. There are some constraints. So let us leave them. So now how to solve this question. So the approach is, things you discussed before. So we are going to use the things which are loops, conditions, array list. These are the three things we are going to use. So some variables to track the indexes. So now steps or our logic is, as we can see, the given three arrays are in the sorted order. So this is our key step to utilize that. So how? So step 1 is declare the So we will declare all the variables which are the index variables to track the current index for all the arrays like I, j, etc. So after that, while loop to iterate all the three arrays simultaneously and iterate all the three at a time using a single loop, which optimizes the approach. So after this is, after completing the while loop, so if the check if the three current elements are equal. So if they are equal, then add 1, 2 and increment all So if all the three elements are equal, then we are coming to know that the particular element is a common element from the three arrays. So add one of the element to the result and increment all three indexes, because it is to show that those indexes are checked and executed, means they are traversed successfully. So now after, If that is not a equal to case but the incrementing case, then if array 1 element is larger than if array 1 element, the current element, is the smallest element from the other two, then increment it by 1. So we are moving forward from the smallest element from the 3 current indexes each time, one by one step. So if same array 2 element, so if not array 2 element and array 1 element, then it is definitely array 3. So increment array 3 index by 1. So at last so we got the output into the RES array list. So return the output as it is. So we mainly use the index traversal and the sorted nature of the 3 arrays in this program for our benefit. So we use the variables like I, j, k, the 3 variables, all initially starting with the 0. We know that indexing starts from 0. So one by one we check with all the 3 elements are equal, then add them into the one of the element will be added to the list and all the 3 indexes are incremented. And next same again, if it is not a equal to case but rather the moving forward case, then if array 1 element is the smallest, increment it, array 2 is the smallest, then it incremented, if not 3, not both, then the other one. So this is in that way continuously the elements are traversed one by one until all the ijk variables will be reached to the end. So that's it. This is what the logic we are going to use. So now if you see the program, first let's declare the type of the return type, which is list. We should know that list, it is not a array list or a linked list or other etc. So list is a interface under which comes the array list, linked list, etc. So list cannot be instantiated. So we use any subclass or the extending class of the list to initialize. So one of the easiest extending class of it is array list. So just initialize it. So take 3 variables, I equals to 0, j equals to 0, k is equals to 0. So now I is equals to 0, j equals to 0, k is equals to 0. So now all the 3 current starting indexes are computed. So now while I less than I should be not exceeding the length of its array list, and same goes with the j, and also k less than array 3 also. So after this we check if, let us keep them separated. Length 1 is equals to length 2 is equals to length 3 is equals to so after the length we will L1, j's corresponding length is L2 and k's corresponding length is L3. So this is how it is. So now int a is equals to element from the array 1 dot get of 5, and coming to the b is equals to 2. We are just saving for keeping the code's logic clean, comma c is equals to array 3 dot get of k. So initializing completed. So if we know that a is equals to b and b is equals to c, then we can say that both are equal. All the three elements are equal. Then if the alias dot contains the a, so all the three values are equal, so you can use any one of the value. So if the output already does not contain the result which we computed now, then only add, because if you see here in the note, they said to handle the duplicate values also. So simply handle that by using the contains. So if it is not present, then only we will add. So result dot add a. So after that I plus plus, j plus plus, k plus plus. So if it is not the case, else if a is less than or equal to b and a is less than or equal to c, then I plus plus. Else if b less than or equal to c, a, and b less than or equal to c, means j plus plus. If not, then k plus plus. Return RAS. So if you see, compare with our steps, so declare the variable to track, declaring is completed. So check if the three current elements are equal using the while loop is within the while loop. So while loop is started, we initialize the three numbers, we check if they are equal. If they are equal, then we check if our result already contains the element. If it contains, then don't add again to handle the duplicates. So if it is not present in the result only till now, then only add the element. So after that we checked because the three values, then same increment the three values at a time. So else if these three cases are for incrementing the, so to move forward one step from the array, which element is the smallest from the three current elements. So if array 1 current element is the smallest from the other total 3, then it's incremented by 1, its index I. So same goes with the array 2 and array 3. So if you see the sample test case, it is passed. Coming to the hidden test cases, we will see. So you can see our approach is written here and all the things are here. So you can see the test cases are passed. So one more time we will submit because we removed the comments. So if you see our code here, the given array 1, array 2, array 3 are specifically used here, and this code looks a very structured way. After the execution, we will analyze the time and space complexity. So let us write now only. So we know any dynamic sized space will be big O of n. So we can see the test cases are passed. So now we will see if our time and space is matching. Big O of one space, big O of n time, because the input dependent execution, big O of 1. So we can see this space. Result size can be anything based on the input only. So it is big of n, and these variables take the constant space of 4 bytes each. So it is big of 1, and this loop is also dependent on the input. So it is big of n. These variables are also constants, means the constants 4 bytes for each. So it is big of 1. So if we conclude the overall time and space, which is big of n of, what is it? It is the time. So time is big of n, and coming to the space is equals to approximately like big of 1. Because of big of 1 means, we said earlier that any extra space which we declare is if purely for the purpose of the output declaration or output only. So this 1 big of n storage is just used only to store the output and return it. So it is not any other purpose of our own logic, means this was not declared for our own logic purpose only, but just declared for the output. So it is big of 1. So if anything which is declared for the output returning or something like that, so we'll ignore it into the consideration of that space. So rather than that, the other spaces are big of 1 and big of 1, which is big of 1, and the space is big of n. So time is big of n and space is big of 1. So if you see they said big of n space, so we didn't use any extra space. So if we consider the output declaration is also as an extra space, then also our code is acceptable. If not considering also, then also our code is in the safe side. So this solution is the best possible solution for this program. So understand this program, kindly go and practice the problem. The program link is given in the description. Thank you for watching. Subscribe for more videos.